Day 530 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3350, adjacent increasing subarrays detection 2. The difficulty level is medium, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an array of nums of n integers, your task is to find the maximum value of k for which there exist two adjacent subarrays of length k each, such that both subarrays are strictly increasing. Specifically, check if there are two subarrays of length k starting at indices a and b, where a is less than b, where both subarrays nums a all the way up to nums a plus k minus 1 and nums b all the way up to nums of b plus k minus 1 are strictly increasing. The subarrays must be adjacent, meaning b is equal to a plus k. Return the maximum possible value of k. A subarray is a contiguous non-empty sequence of elements within an array. All right, y'all, so that may seem a little bit confusing, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, if you have been following along with this channel, you know that we did the first version of this problem yesterday, which was adjacent increasing subarrays detection 1. So if you missed that, I suggest you go check out yesterday's problem, day 529. It's sort of like a prerequisite to this problem. Yesterday, they gave us k. This time, we have to find k ourselves. That's the difference. So let's get into it. Now, once again, first thing we need to do is we need to understand what a subarray is. So a subarray is a contiguous non-empty sequence of elements within an array. So all contiguous means is that the elements are in a row, like 7, 8, 9, that's a subarray. Contiguous subarray 2, 3, 4, that's a contiguous subarray. Now, if it was like 2, 7, 4, 1, that's not even though those elements are in the array and we could create a subarray with that, that is not a contiguous subarray, right? Or excuse me, I don't even know if we could create a subarray with that, but either way, it wouldn't be contiguous, right? Contiguous means it's the elements are right next to each other like this, right? It's not just picking one number here and picking one number here and picking one number here. No, they all have to line up right next to each other. Another thing another thing that is important to understand is when we are finding our two subarrays, they need to be adjacent to each other, right? So the two subarrays need to be right next to each other. So this subarray is right next to this subarray, right? It's not like we're picking this subarray here and then we're picking another subarray all the way over here. No, we need to pick a subarray here of strictly increasing, and then right next to it, we need to pick another subarray here that's strictly increasing. So as you can see, this subarray 7, 8, 9 strictly increasing. This subarray 2, 3, 4 is also strictly increasing, and they both have a length of size 3. So let's go ahead and take a look at examples to break it down even more. So in example 1, we have our input nums equals an array of integers 2, 5, 7, 8, 9, 2, 3, 4, 3, and 1. Our output is 3. The explanation says the subarray starting at index 2 is 7, 8, 9, which is strictly increasing, and the subarray starting at index 5, 2, 3, 4, which is also strictly increasing. These two subarrays are adjacent, and 3 is the maximum possible value of k for which the two such adjacent strictly increasing subarrays exist. So let's break this down one step further. So what we want to do is we want to find two subarrays that are strictly increasing, that are right next to each other and have the same length. So these two subarrays fit the requirements. This subarray fits the requirements, and this subarray fits the requirements. And as you can see, these two subarrays are right next to each other. They're adjacent to each other, starting right here. Boom. So once again, you can see this subarray 7, 8, 9 increases the whole time. It's strictly increasing, and there's 3 elements in it. This subarray does the same thing. It's increasing the whole time, 2, 3, 4, and it's right next to the first subarray, which is what we want because they're adjacent to each other. And they're strictly increasing, and they both have a length of 3. So we want to find the maximum length that we can create. So these both have a length of 3, right? So if we started here, this would have a length of 4, but this wouldn't have a length of 4 because it stops right here. The increasing stops right here. It goes 2, 3, 4. That increases, but then it goes back to 3. That's decreasing. So we can't use that. That wouldn't work. Even though it will work on this side where it's strictly increasing, it wouldn't work on this side, so we can't use it. However, if we do 7, 8, 9, that has a count of 3, and 2, 3, 4, that has a count of 3. Those both have the same length. Both of those are always increasing, so we could just return that length of k, which in this case is 3. So just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input nums equals an array of integers 1, 2, 3, 4, 4, 4, 4, 5, 6, and 7. Our output is 2. Explanation says the subarray starting at index 0, 1, and 2, which is strictly increasing, and then the subarray starting at index 2, which is 3, 4, which is also strictly increasing. These two subarrays are adjacent, and 2 is the maximum possible value of k for which 2 such adjacent strictly increasing subarrays exist. So in this case, we're doing this subarray and we're doing this subarray, right? As you can see, this whole subarray is strictly increasing, but we will need the next 4 numbers to also be strictly increasing, and that's not going to work. So that's why we can't just say 4, right? Because the subarrays that are adjacent to each other are right next to each other both have to have the same length, and they both have to meet all the requirements of being increasing. However, when we do this subarray, right, that's 1 and 2, that's strictly increasing, that has a length of 2. Then we do this subarray, which is adjacent to the first subarray, which is what we want, also has a length of 2, and it is also increasing. It goes from 3 to 4. So since these two subarrays are adjacent to each other, and there is no other 2 subarrays that are adjacent to each other with a greater length, right? So, because there's also a subarray here, 4, 5, and 6, and 7, but they still have a length of 2. So either way, the output is going to be 2, k equals 2, because the length of this subarray each adjacent subarray is 2. So I hope that makes sense to y'all. And now that we understand the fun part, let's get into the actual solution. Solution is not that difficult at all. So the first thing we're going to do is we're just going to initialize an array that's going to store the length of all strictly increasing subarrays found in nums. So we could just declare a variable. We call it length array. Sorry, y'all. We call it length array. We'll say colon. It's going to be open up the square brackets. It's going to be an array of integers, and we can initialize it like that with a blank array. Now we need a counter to track the length of the current increasing sequence that we're looking at. So we could declare a variable called cur count, and we could set that equal to 1. Boom. Then we need to store the maximum length of an increasing subarray pair that we have found so far. So we need to create a variable for that by saying var max len, and then and then we could say colon, that's going to be an integer, and we can initialize it to start at 1. Now we need to iterate through the array starting from the second element. So we're going to say for I in 1 ... less than nums count. We're going to open up the brackets, and if the sequence continues increasing, we're going to extend the current count by saying if nums square bracket I minus 1 is less than nums square bracket I, then we're going to open up the brackets and we're going to say cur count plus equals 1. Boom. Then we'll come right here. We're going to say else. We're going to open up the brackets, and if the sequence breaks, then we're going to record the length of the previous increasing run. So we're going to say length array dot append, open up the parentheses, and pass in cur count. Boom. Then we need to update max len using half of the current sequence length, and this represents pairing 2 equal length increasing parts. So we come underneath this and we say max len equals max, open up the parentheses, max len, comma, cur count divided by 2. Sorry, that should be a 2. Boom, and then we need to reset the current count for the next potential increasing sequence by coming underneath this, and we're just going to say cur count equals 1. Boom, then after the loop, we're going to process the last increasing sequence. So by coming right here outside of the for loop, we're going to say max len equals max, open up the parentheses, max len, comma, cur count divided by 2. Then we're going to come underneath that and we're going to say length array dot append, open up the parentheses, pass in cur count, just like that. Now we need to compare adjacent increasing subarrays to find the maximum overlap. For each pair of consecutive increasing segments, the valid increasing subarray length is limited by the smaller of the two. So we come underneath this and we say for I in 1 dot less than length array dot count. We're going to open up the brackets and we're going to say max len equals max, open up the parentheses, max len, comma, min, open up the parentheses, length array, square bracket I, come outside that square bracket, comma, length array, square bracket I, square bracket I minus 1. Boom. Then we need to return the maximum valid length found by coming underneath this and we say return max len. Boom, y'all, that's all she wrote. Let's give it a run before we submit it. Make sure it runs correctly. Okay, we got an error. Y'all, let's see. Can I find length array and scope? Oh, so let's just fix this. Make sure the spelling's right, and let's run it again. Let's see, it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 632 milliseconds beats dash percent of users. I don't know what that dash means, but we'll take it, y'all. Memory looks good. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.